Okay, guys, I am going to have the video for the notes for 10-6. So obviously, if you can get your notes out for 10-6, I'm a little behind on the video making because I'm just learning out what the heck is going on. But let's just go real quickly. Um, this is going to be circles and arcs, in particular the arcs. Just a couple of vocabulary. The circumference is the distance around the circle. So you should know what the circumference formula is already. It is 2 pi r. That means if I want to know the entire way around the circumference, the circle, it is 2 pi r. It'd be in inches and centimeters and so forth. You've all seen the symbol pi. It's right here. It is approximately 3.14. There is a relationship between going across the circle, the diameter, and the circumference. Going around the circle is 3.14 times bigger than the diameter, which is going across the circle. Now, here's the key. The arc, which is just a portion of the circle, like this is an arc right here, highlighting in red, and it has two things. An arc has a degree measurement, maybe 80 degrees, 90 degrees, and so forth. And it has a physical length. Like if you took a ruler, I can bend it around this red arc here, and you could figure out how many centimeters it is, how many inches it is. And we're going to calculate the length later today. Central angle is the angle in the center of the circle. It is equal to the arc. So if I'm dead center and I'm 90 degrees, then the arc out here is also 90 degrees. That's the center angle. Concentric circles, don't worry about. Just this next rectangle here is just vocabulary. Notice right here it says arc T, then go to R, then go to S. You got to follow the way of the letters T to R to S. This is a semicircle, which is half a circle, and a half a circle is 180 degrees. The next one over is RTS. RS. So it's just the shortest distance, R to S. Don't go the long way. We'll explain how to go the long way in a second. Now, this is less than half the circle, and we just call this a minor arc. And the next one will be an example of a major arc, which is more than half the circle. And you're going to have to take notice on the way it's labeled with the letters R, T to S. So you start at R, then go to T, then go to S, as opposed to the previous example where it just goes R to S. When you have major arcs, you're usually going to see three letters, R, T, S. Okay. Moving on, 10-1 here, this is kind of just common sense. This is arc addition. Basically, we're just going to add two arcs. We're going to add the green arc plus the red arc equals the entire arc from here to here. It's just common sense. Arc ABC is arc AB with that little rainbow above it plus arc BC. Okay. Circumference of a circle, again, that is the distance around the circle. Circumference is two formulas. You can either use 2 pi r, r being the radius, two radiuses times 3.14, or you can take two radiuses is the diameter, so you could be pi times the diameter. Okay. And then finally, the most important theorem of the day is going to be arc length, not arc degree, arc length. And so if I want to know the physical distance of this red arc here, how long is it in inches, in centimeters? Here is the formula. You would take the arc degree, and that could be 90 degrees, 80 degrees, who knows, divided by the entire circle. How many degrees is an entire circle? Well, that's 360 degrees. That would give you the percentage. This fraction would give you the percentage of the circle that is red. You're going to multiply that by the circumference formula, which is 2 pi r. All right, and then 2 pi r is the whole circumference. And basically, when you multiply it with this first fraction, you figure out just the red portion. Whoops, I'm running out of room here. Okay. And I'm going to stop the video for this first section and continue on in a moment.